Hello everyone. Today I am going to move on to the last scheduling method. We call it the Program Evaluation and Review Techniques, commonly known as the PRT. Now, this particular scheduling method is based on probability, so it is more on probabilistic approach. The PRT was introduced in late 1950s and early 1960s, pretty much the same as the critical path method. It was developed due to a project that they created by the Department of Defense known as the Polaris missile. The program evaluations and review techniques is commonly used for activities or project that has not much of a basis on the durations of the activities involved, such as for industrial type of project. Again, this particular scheduling method is used for complex type of project or those that are specialized in nature, such as again the industrial project. So since it is based on probability, you will see that as we move on, you will notice that some of the values that we will be calculating are terms that are related to probability, such as the standard deviation, variance, and average. Alright, so PRT is an event-oriented network analysis technique used to estimate project duration when individual activity duration estimates are highly uncertain. So again, this particular scheduling method is commonly used for project that has an uncertainties on the duration of a particular activities. The PRT only applies to those activities that are considered to be critical, because the activities that are within the critical path are the ones that determine the duration of a particular project. So PRT focus more on the activities that create the critical path. Okay, so again, it only applies to critical path by means of a weighted average duration estimator. There are several terms that we will be looking at as we move on to the use of PRT. Now we will be seeing variables such as TO, TM, TP, and some other statistical term. Let us define each of those. So unlike the critical path and the Gantt chart and the LSM, we have only one durations that are involved. In the case of the PRT, we will be involving three different duration. One that is we call optimistic duration. The other one is a most likely duration, which is actually the average of the durations that we will be calculating. And of course, we have the pessimistic duration. So the TO, which is the optimistic duration, is the amount of time the activity will take if everything goes smoothly and efficiently. So that is a little bit of a positive side, assuming that nothing will distract or cause any problem on a particular activity. Now, in the case of the TM, again, as I've said a while ago, it is the average of the durations between the TO and the TP. The TP is the pessimistic duration. It is a duration under the almost worst case scenarios. That is the conservative type of durations that having the assumption that if something happened, this is how long will it take for a particular activity. So you will be dealing three different duration per given activity. In addition to that, you will see also a calculations for T with a subscript of small letter e that correspond to the expected duration of a given activity, because later on you will see that there is also a capital subscript E that correspond to the durations for the entire project. So again, for each given activity, it is designated with a time with a subscript of small letter e. So to calculate the expected durations of a given activity, we just be needing the average value of the three times durations that we have. It is a sum of your optimistic duration 4 times the R-weighted, which means that the mean value is 4 times, then plus your TP. So because we have 4 plus 1 plus 1, we need to divide it by 6. In this statistic, that is what we call the average duration. Now, who will be responsible in determining your TO, your TM, and TP? Of course, it will be the project managers, to which he will be utilizing every resources, including his experience, for them to figure out those 3 different duration. Alright, so in addition to that, we are going to determine the standard deviations and variance of each given activity. So you'll notice here, there is a subscript of E, a subscript of small e here. Alright, so what is the standard deviation? In layman's term, the standard deviations is like a tolerance. It is a plus or minus, a value that we can only deviate lower or higher. So how do we determine that? In construction, we have the difference between the pessimistic and we have the optimistic and divided by 6, and that is the standard deviation of a given activity. And then of course the variance. Variance is the difference between the upper limit and the lower limit. So in our case, it's just the square of the calculated individual standard deviation of a given activity. So you just need to square that. And by the way, as I move on to this one, I would like you to download 2 different things, 2 documents that you need for this particular topic. The first one is a Z table, and the second one is a format. Let me show you that. On your Blackboard, okay, under your, it says here, your supplementary documents and forms. So I want you to click that one and you will find all those forms that you need. Okay, so we have here the Z table. That's one of those forms that we will be needing. Okay, and the other one is the PRE 2016. So you need those 2 for this particular lesson. So I want you to download those. Make sure that you organize your USB folder so that you will be able to create that subfolder within your class CNBD 2335 so that it will create a much organized information. Alright, so again, as I'm going back to my PowerPoint, I have here now the capital E that correspond to the duration for the entire project. So to determine the duration of the expected duration for the entire project, you just need to add the expected duration in each of those calculated expected duration of each given activity. So those are the T with a subscript of E. So you just need to determine or add up all the duration in each of those expected duration of the activities. The same thing also with the standard deviations of the whole project and the variance. Here in this case here, we need to calculate first the variance, and that is the sum of the square of each standard deviation of the activity. So you have to calculate first the standard deviation of each and then sum it up, and that gives you the variance for the entire project. And that gives you now, by plugging into this equation, and that will give you the standard deviations for the entire project. And by the way, on your handout that I gave you, I asked you to download this one here, the PRD. Okay, so you just need to click and download it. For that particular format, you want to just plug in values and it will automatically calculate the rest of the other columns that we will be needing, such as the T small e, the standard deviation of each activity, and the variance. So in this particular case here, we already have set up formulas, but one thing that I want you to Take note is don't mess up in this shaded area here because we already have a predetermined formulas in each of them. All right. Okay, so let me go back to my lecture here. All right, so again, once we have all those calculations, we will be able to calculate the z values. The z value is a value that will guide us to determine the probability that a particular time may occur, or the confidence whether a particular duration is enough to complete a particular job or a particular activity. So again, the z values is found on the z table, and you need to download that from in this supplementary documents here, and you have the z table here. So make sure that you're going to download that because we will be needing it. Okay, this is the z table. Okay, and I'm going to explain that how to use it as we move on. Okay, all right. So let's have this problem here to illustrate how to calculate or use those different formulas. So again, assuming that your activity A, B, C, D, and E as given here are all critical. Remember, as I mentioned a while ago, that the program evaluation review techniques is applicable for those activities that are within the critical path. Okay, now it's here I just assume that all of these activities are critical, and there is a given 3 different durations: the optimistic, most likely, and the pessimistic. So what you to do are plug in these values into our format. So you just need to plug in all of those, replace the different activities here, okay, and then it will give us the calculated values, and then we are asked to calculate each of these conditions here as part of the problems. All right, so what I did, plug into that format that you have in Excel, plug in all the values 2, 4, 7, and you will notice that it automatically calculates the values of the expected duration of each given activities. Not only the duration, is also the standard deviation, variance. But one thing that I ask you, don't mess up the formula that you have on the shaded portion. So please, okay, stay away from that. It is automatically calculated. If you mess up, you can go back and download the format, okay, and then plug in those numbers. As you've learned probably in your estimating too, you can protect the shaded portion by protecting the cell and protecting the workbook. Okay. Alright, so plug in those numbers, it automatically calculates the rest, all those shaded portion, including the standard deviations for the entire project. Take note again, there are several letters here or variables that you will be dealing. The small e here correspond to the activity. The capital letter E here correspond to the entire project. Alright, so take note, we have the expected durations for the projects, 32 days. The variance for the entire project is 8.83, and the standard deviations for the entire project is 2.97. So those numbers here, those are automatically calculated based from the format. So make sure that you download that particular format. Alright, so we're now ready to calculate the questions. The first question was, what is the probability that the project will finish by the end of day 32? So by the end of day 32. So this one, it helps the project managers to make decision, because if the client will ask you, Mr. Project Manager, what is the probability that the project will be finished on a particular length of day? Well, you will be able to give them a theoretical mathematical calculation or assurance of the probability of completing a particular project at a given time, and that is making use of the Z table. So our TS in our formula here, that is the duration that is in question. We have here the T with capital E that correspond to the expected durations of the entire project. So we are asked to calculate what is the probability when the TS, okay, that is the day in question, that is less than or equal to 32. So to do that, plug into our equation from our slide 32, that this one here, that's your TS, minus 32, that is the one that we have here on your Excel. So that will give us 0, right? So what is that probability that will give us a Z value that is 0? So we are going to use your Z table here, okay? The Z table, it has rows and columns. The first row corresponds to the 10th or the 100th decimal, and the Z table corresponds to the first whole number and the 10th of the numbers. Say for example, if I have here 1.15, and that will be 1.1 plus 0.05, this one here. So if you have 1.15, that will be located within the row of 1.1 and within the column of 0.05, because 1.1 plus 0.05, that gives you 1.15. Alright, so for this particular problem, problem number 1, 0 in your Z. Where is the 0? That is here, the first line and the first column. And what is the probability? That is 0.5. That is a decimal value. So we have here 0.5, and that is equivalent to 50%. So therefore, or thus, the probability that we'll be able to finish less than or equal to 32 days is 50%. Alright, so again, as we move on, I'm going to illustrate how you use the Z table. Alright, let's go to problem number 2. What is the probability that the project will finish by the end of day 34? So your TS here is 34 by the end of day 34. So plug in again into our equation. Your TS is the one that we are asked, okay, to determine the probability. Your TE is the value that you calculated from the table, okay, this one here, this value. Alright, so plug in the numbers. Your TS is 34 minus 32 divided by 2.972. That gives you 0.67. So I want you to limit the decimal value in the 2 decimal point. So in that case, we have 0.6. We have to locate that on the first column, and the remaining decimal will be on the row. So in this case, that's 0.07. So 0.6 plus 0.07, that's 0.67. So draw a line from that 0.6, go across and draw a line that going from the top, from your 0.07 going down until you intersect those two. So in this case, the intersection of your 0.6 and your 0.07 is 0.7486. So that is the probability, which is 0.7486, which is equivalent to 75%. So what does that mean? If your client asks you, what do you think is the probability that we'll be able to finish in 34 days? Well, you could tell them that based from your educated knowledge, your knowledge or your education, you have calculated based from the statistical method that we will be able to finish the project 75% for the day 34. All right, let's move on to the third question. What is the probability that the project will finish before? So take note of that. On the previous problem, we are asked the end. In this case, that the project will finish before day 30, which means that is before day 30. That means 29. So that is your TS. Plug in again to our equation, TS minus T, and that will give you negative 1.09. So I want you to take note, if it gives you here a negative, for us to be able to use the table, we will drop that negative sign and treat this as a positive, just for us to get the value of your Z. So the positive value for 1.01, so it's 1.0 and 0.01, so 1.0, 0.01, draw a horizontal line, draw a vertical line, they will intersect at 0.8438. This value here corresponds to the probability of a positive 1.01. So you might be asking, well, we get a negative. Well, this is how you're going to do. Provided that you calculated your Z value as a negative, first, you're going to treat that as a positive to get your Z value from the table. However, once you get that value, you subtract that from 1, because we will be getting a value that is below the curve. So again, we subtract that probability from 1 only if your Z value is negative. So again, we treat the Z value as a positive. We look that up from the table, and whatever that probability, you subtract that from 1. So in this case, the probability that you will be able to finish before day 30 is equal to 15.62. Hopefully that is clear to you. Again, if the value is negative, just treat that as a positive only for you to get the value of your Z and able to look up data from the Z table. However, if it is a negative, that probability that corresponds to that positive 1.01, you have to subtract that from 1 to get the correct answer. So in our case, our answer will be 15.62. Remember, in the first problem, the probability of 0 is 50%, which means anything that is less than 32 days, those should be less than 50%. So that is your key, okay, as you move on. Let's go to question number 4. The probability that the project will finish by the end of day 35. By the end of day 35. So we have here 35. Plug into your equation. 35 minus 32 divided by the standard deviation is equal to 1.01. So in that case, we need to look up this value 1.01, which again, that's equivalent to the previous equation. So we have only that we will treat it as a positive. We don't need to subtract from 1 because your Z value is positive. So in this case, it is 84.38 for day 35. Okay. Let's go to your number 5. This is different now. What we have here in this problem, it gives us the probability, which is 90%. That is the confidence. Again, the client may ask you, Mr. Project Manager, what day that we will be able to finish that 90% probability? Well, you should be able to answer them using this particular method. So if that is 90%, we will be looking up that 90% into our table in order for us to determine the Z value. So it is the reverse. It gives us the probability rather than finding the probability. The given is the probability value. So we need to look up and find this 90% on the table that is equal or less than the 90%. Again, equal or less than 90%. You cannot go above. So let's find that on the table. So you have to scour your table until you find that 90%. So in our case here, we're going to use 0.8997. Why? Because the next number is greater than 0.9. So remember, the closest to that 90%, but it must be less than or equal to 90%. So in this case, we have 0.8997, and that is located at 1.2 plus 0.08, that is 1.28. And then we will be using your formula again, Z TS minus TE divided by the standard deviations for the entire project. Take note, what is being asked here is your TS. We don't know the TS. So plug in, we have 1.28, that is your Z value that we get here. So 1.2 plus 0.08, that gives you 1.28. So TS minus 32 divided by 2.972, cross multiply your 2.972 to this one. So we have this next line, and that gives you TS minus 32. Multiply this, transfer your 32 to the other side of the equation, that will give you 35.8, or that is equivalent to 36 days, which means that the 36 days will give you a 90% confidence level of 90%. Alright, so that is for day 36. Let's take a look at another problem here. Okay, the completion date with at least 95%. This time is 95%. So we will be looking up where is this 95% on the table. When you look up the table, the closest value to your 0.95, okay, is again for 90%, 95%. So I mess up here. That should not be in there. It should be 95%, is corresponding to 1.64 from the table. So when you look up here, that should be located from 1.64. Okay, going back into here, that should be on your 1.64, this one, and under your 4, okay, this one here, going down, this is your closest to 95%. So it is located at 1.64. We cannot use 0.9505 because it's above 95%. We cannot use the next one because it's above 95% as well too. Okay, so we use 0.9495, and that is located at 1.6, and that is 0.04, and that's what we got here. Okay, that's why that 95%, again, this 0 here should not be in there, should be 95%, is 1.64. Plug in that to our equation. That's your Z TS minus TE all over the standard deviations of your E. So where are we getting this value again? From the Excel. Okay, this one here at the bottom, that is where we're getting that 2.97, and I just use the 2 decimal places. Alright, so with that, plug in the value, cross multiply, arrange the equation, and it will give you 37 days, which means that the 37 days will give us a 95% confidence level, because the client may ask you what day that will give us 95% probability. Well, your answer will be 37 days. Alright, so that is the illustrations that we have. As usual, I uploaded a supplementary documents in Blackboard that explain every slide or every steps on these calculations. So again, if you have any question, reach out to me, send me an email, so I'll be able to help you and guide you. I want you to complete the semester successfully. Okay? I know and understand that sometimes it is difficult to go over with the step-by-step. However, you have the supplementary documents that you can always go back and look whatever that one that you miss on these videos. Okay, and that will give you at least it helps you going back again into the explanation. So again, this is our fourth scheduling method. We call it the program evaluations and review techniques. Next time, I'm going to move on into the project controlling, and we're going to begin with the S-curve. As usual, send me an email if you have any question. You have the supplementary documents. You have the videos. I'm going to upload also the PowerPoint. Hopefully, all of those documents will help you and guide you for this particular topic. All right, until then, have a good day.